Oh, I'm muted and I've been speaking for a while. All right, so welcome to breakout call number 9. I posted a link to the agenda in the chat. I suspect that the best thing we can do is to start with Julian, that wanted to have a brief presentation on issues arising with slot auctions. It should be a short call. There are not many things to discuss, but it's I guess it's better if we start with Julian. Can you take it from here?
Sure, thanks. Let me try to share my screen. Is it visible for you guys? Nice.
Yeah.
Okay, so I just wanted to present a hypothesis for an argument that shows there's a trusted advantage in slot auctions. It's fairly convincing for me, and I've presented to some people within Robust Incentives Group, but it's not like, obviously it's very far from a fully fledged worked out argument, so please let me know if there's anything. So first of all, what is the no trusted advantage? We want the beacon proposer to be incentivized to use the in-protocol commitments to commit to the block producer that maximizes the proposer's utility. So either it should be the block producer that produces the highest value block, or maybe the proposer has some valuation for producing the block itself because it wants to influence the ordering of transactions, for example. Whatever the proposer's utility is, it should commit to the person that maximizes it. But the question is, will the proposer indeed use ePBS, or will it use MEV-boost? So a way that a proposer could bypass ePBS is, for example, commit to itself in the beacon proposer in slot auctions and say, I will produce a block. And then 6 seconds later, when the execution payload has to be produced, it runs MEV-boost to get other people to bid and thereby bypass the in-protocol commitments and use trusted relays and other trusted sources so that it's still outsourced block production without using ePBS. And here I present an argument in why in slot auctions, a proposer may choose to do so. So consider a very simple model. There's a proposer that can choose the auction at 2 times, at P0 or at T6, or you could say early or late. And there are builders that try to maximize their tails. Each builder has a distribution of block values it may realize. And at time T0, the builder does not realize value, it only knows its distribution. And at time T6, the builder knows its block value. What we see then is that if the proposer were to choose to auction off at T0, and so actually use ePBS, the builder should bid according to their expected value of the block. So obviously a builder wouldn't want to bid more than their expected value because then in expectation, they would lose money. And depending on the auction mechanism, they should, if it's competitive, be close to the expected value. And if the proposer were to choose to auction off at time T6, so at a later time, builders should bid according to their realized block values. And the key insight here is that the second highest order statistic of the realized values, which is what the proposer may expect to receive at time T6, is under reasonable circumstances likely higher than the expected block value ex ante. So if builders were to purely bid based on their expected value, this should be lower than if builders bid based on their realized value, because there could be some builder that has an exceptionally high value, for example, or just some value that's higher than their expected value. And this would mean that proposer would choose the late auction. So effectively, it would mean that in ePBS, a beacon proposer commits to itself in slot auction ePBS, a beacon proposer would commit to itself as the builder, and then 6 seconds later run MEV-boost and still get a higher price based on the realized block values instead of the expectations.
Can I slow you down for a second?
Yeah, please.
Just the second highest order statistic of realized values is likely higher than the expect. It sounds as if that you're saying with slot auctions that this somewhat enables them to. Maybe you haven't gotten to that part, but yeah, I don't know. It sounds like you were kind of saying that with slot auctions they get the option of taking the later auction and getting closer to the realized block value.
So that's a good point. So in block auctions, you commit to a specific execution payload hash. So the execution payload can't be changed anymore. And so you're kind of forced to auction off at the time that the protocol describes, because the beacon block must be delivered. In slot auctions, you commit to one builder, and the execution payload itself should still change later on.
So
yeah.
Okay. So yeah, if we do block auctions, then it's definitely a bid based on the realized value. But if we do slot auctions, it's based on the expected value. Yeah. Okay.
Yeah, exactly. And so the argument here would be in slot auctions, the proposer kind of has the option to choose whether it would want to receive bids based on expected value or bids based on their realized block value. And so but if it wants to get bids based on the realized block value, it has to commit to itself in the beacon block as builder and then run mevboost 6 seconds later. And the argument here is that likely the realized block values would lead to higher revenue for the beacon proposer, if that makes sense.
Yeah, that makes sense. And I suppose, yeah, it's just that I thought this was a argument in favor of slot auctions, so maybe that's why I'm confused. Or were you saying in favor of block auctions?
So I think this should be it's an argument in favor of block auctions.
Okay.
If
okay.
you
Yeah, that makes sense. Okay, I thought the presentation was done by block or slot auctions, so I was confused.
No, yeah, I should have specified that. But it's an argument against slot auctions. In various other research proposals, such like execution tickets, it's used as an argument in favor, but there are some specifics there that make it good. But yeah, that's outside of this discussion. So the takeaway is that if you choose the auction later, you should expect higher revenue basically as proposer. But then there's a bit of a weird assumption underlying this. And the assumption is that a proposer can use mevboost 6 seconds later to sell the execution payload construction rights. I think this is a fine assumption. It's what's happening now. And if we were to change the current system to slot auctions, and it turns out that it's more profitable to do this, then I would expect mevboost to still exist. And yeah, Protus, go ahead.
Yeah, so I understood the issue. I have no solution to it, and I think we need to think about it. But do you have any idea of like how this changes with timings? I mean, how accurate is it, or do we have statistics as to how much do we expect the difference between the realized and the expected value to be at 6 seconds? Because a proposer that wants to do this will not have much more time. I mean, they won't have the time that they have today into submitting a block. So today to run mevboost, we're already at the limits of latency that we can have. And to run this thing, you're going to have, it's going to be much tighter, I guess. I'm not sure. It might be even worse because the proposer would just immediately announce that they're running mevboost. They will just quickly submit their block committed to themselves at 0. So that block was going to be assured to have proposer boost. And then they can just run the mevboost auction at about 5 seconds and play the usual timing games. This is serious.
Yeah, I think
it's a good catch.
It would work out. Thanks. So I think I wouldn't know about the magnitude of the difference. I think the difference is surely there, and I believe I'm not super sure on these specifics, but I believe that bids are coming in mostly 3.5 seconds before the deadline in mevboost these days. So you should have time during the 6 second interval. Enrico?
Yeah, just thinking about that. Even if you think about the average, but maybe just to catch the potential upside for the outliers where you got a very big MEV thing that happens. So just to be exposed to a very unlikely but very, very big upside, you have these incentives to say, okay, I'm playing, it's just another way of playing the timings here. Just I want to pick the very latest thing that happens, independently by the mechanism. So the mevboost way is the way to keep to delay the choice as much as possible. Essentially, is right.
Yeah, I see your argument. So let me get into it in this slide, because I think it's slightly different. So maybe I don't summarize well what you're saying, but it sounds to me like you're saying if there is some possibility of larger value, I'd want to wait. And this sounds a lot like a risk transfer. So the proposer is based, either the builder could bid early and the proposer gets a fixed value, or it could wait and have a more volatile value that it gets some risk reward ratio, basically. I think so. Yeah, so you can respond to that. Okay.
Yeah, I think you're getting right.
Okay, thanks. So I think this is slightly different from, but let me just quickly finish this thought. And then I think it's slightly different from a risk transfer, because in this, I assume that the builders cannot effectively resell their execution payload construction rights. So that's the second point on the slide with the question mark. This is an assumption I make here. If a builder would be able to effectively resell, then this result doesn't exist, and proposers would probably sell early. But then to ensure that builders could effectively resell, it means that you have to have like a secondary net boost market pop up. So I think the true result here is that whether slot auctions have a trusted advantage or not really depends on the state of the secondary market, and it's quite fragile. So yeah.
Yeah, I got this. Yes. Now I see what you're making.
Nice.
So part of a mitigation to this is, I think I got something wrong. So a proposer that wants to participate in this way should not submit at zero, committing to get an auction later, because it might actually happen that he gets a good bid now. And so at the very least, he should evaluate whatever bids he gets, even if it doesn't request some bids, whatever bids there are on the P2P layer, for example. And the problem is that if you do this thing, then whomever, the secondary market is already, how to say this? If the builder decides, if the proposer decides, I'm not going to commit to any of these bids that are outside already, then he might actually end up losing money, right? Because he's doing this early, he's looking at bids, and he's still committing to himself for zero value. Not really sure. I'm just ranting off the top of my head. But there are two problems that I wonder how much the builders can actually trust the proposer in this situation. The proposer can always equivocate and include whatever block he wants. And unbundling protection of MEP boost would probably not hold here. So I'm not really sure. Because the proposer himself is the builder, and the builder boost is huge. So if the proposer commits to himself and gets a boost, he can probably reorg and unbundle the builder. So if there are bids outside, that's the thing. Under the current ePBS proposal, I think it's easy for the proposer to screw a MEP boost builder.
Yeah.
And this is in the
that's
context
interesting.
this is in the context of this is in the context of slot auctions after they've committed to building themselves, or
it's in either context. If you run any sort of like MEP boost auction, because you can do a MEP boost auction also for block auctions as well. You commit to yourself, and then you just put the hash that whomever gives you. But the thing is that the system is designed in a way that the protection for the builder is so high that if the builder gives away this protection by allowing the proposer to sign as a builder, I think the builder can be unbundled. So I'm not really sure how many builders will be willing to play this game.
Wait, okay. I think I'm missing something somewhat
You have to trust the relayer here, right? Because when you run the MEP boost auction at, say, the 8.9 second mark, the play timing game, you have to go to the relayer, and then the relayer will be the one that's releasing the final block, basically.
Yeah, but if you, if the relayer needs to make sure that no equivocating block is going to come out, especially in slot auctions where we're not even punishing equivocations. So we're not even punishing equivocations on the payload. If the proposer is smart, he can unbundle. Yeah, actually, I don't know.
But it's not same slot. but then it's not same slot unbundling, right? I think this will be the
It
next
is same
slot.
slot, right? It is same slot. You just, if you manage to get a hold of this payload and you submit quickly another payload that wins, for whatever reason it wins, you just unbundled the builder. And the builder doesn't get any protection because the key that is signing this payload is anyways is going to be the validator.
So maybe as a validator, you could commit to a relay being like the relay being the builder in your beacon block, and then the relay hosting the MEF boost auction.
Yeah, that's true. Yeah, that's true. The relay would be the relay would be, but that actually this way, yeah, that's true. So this is an honest, trusted advantage, but this is something that not that the fact that there is an advantage, but it's something that we wanted to happen anyways, right? We want to have a secondary market in which the builder resells these blocks. So this I don't mind. If the builder, which is in this case would be the relay is buying the rights to do a slot auction, and then the relay resells the rights to the builder to build the block. This is fine because whomever is buying this auction is in the protocol and is already staked. So
yeah,
what you're describing is that perhaps there is an advantage is a centralizing force in that the relay will always win this, and the validators would always sell to the relay.
Yeah. Okay, that's interesting. Okay, let me quickly get to the last slide. So this slide is my opinion, and it's so it shouldn't be taken as facts. Just curious to what you guys think about it. So to me, looking at this argument, it looks like slot auctions is very fragile to what the secondary market looks like. So specifically to whether the proposer has more options in the secondary market than a sophisticated builder would have. So basically, the question is, if the auctioneer is sophisticated, would you be less willing to participate in the auction than if the auctioneer is unsophisticated? And so, for example, if the secondary market attracts fewer bidders, if the builder runs an auction, then proposers won't choose to use the ePBS auction, but will use the MEF boost auction instead. And so potentially that's fine if you count like the relay thing. But yeah, and then also there's like a lottery aspect. So you could see as a revealed preference now that proposers, for example, don't participate in smoothing pools, that they're very, very risk seeking. And so if proposers are less risk averse than builders, proposers would also want to wait later. And this is basically the point that Enrico was making. And so they would use the MEF boost auction. Potentially this is less bad because then it means that risk is just something that they like. So they are maximizing their reward by committing to themselves, which maybe isn't technically a trusted advantage, but something to be taken into account. And so since it's so fragile, and since we're already in a regime of MEF boost now, to me, it feels like if all of this indeed holds and the assumptions are reasonable, then it could be that in slot auctions we get that either almost 100% or almost 0% of the time they're actually used. And this to me sounds quite bad. And if we're in a regime, it will be difficult to move out of it. So then my question would be like, what do we need to know to decide on this? Because it's quite difficult to predict what the secondary market will look like. And it could also change, of course, over time once ePBS goes live. Yeah, so that's it. So curious to hear what you guys think about it.
I have a question, Julian. So would you say that this type of a problem will exist no matter what in any type of future auction market, right? Because you can always just have like instead of committing to a builder, I just commit to a relayer, and then basically the relayer will just release the best block at the time once the auction ends or once the 6-second mark. Is it a fair statement to say this type of problem will always exist, whether it's like a slot auction or like a future execution auction or execution ticket?
For any like slot auctions, let's say execution auctions are also kind of slot auctions. For block auctions, I think it won't exist because you have to commit to the execution
period. You have to commit to the yes.
Yeah, but and I think for further ahead auctions, you're basically forcing the sale via like MEF burn or something. So you're basically saying the proposer must sell at this point unless you're willing to pay a high premium for it. And I think this will have a big effect on the secondary market. So I'm not sure if it will always exist. And intuitively, I would say no, you wouldn't have this if you sell, for example, to epoch in advance. Yeah.
So just, I just want to clarify that the secondary market is the like selling that takes place after you've committed and said you've chosen a builder, but it's really you, and then you're going to sell it again. Okay, and then
Yeah.
So
Yeah, it should.
and the question-
basically, imagine you just commit to a relayer instead of a builder. You just commit to a relayer, and then the relayer just basically get the best block and just propose it, right?
Yeah, that makes sense.
I don't think it is the relay. So there are two components to this sort of like attack, to this problem. If I just commit to a relayer and I sell, and my block includes a header or a bid, whatever it's called, with a value that the relayer will pay on chain, and then the relayer resells, that's fine. That's predicted by the protocol, and this is something that we can live with. That's not off protocol. I think the problem that Julian is describing is that even if I commit to a key for the relayer, I am getting my payment off protocol. And the whole auction is being carried outside of the protocol. And this sends builders cannot compete against this relayer, because the relay will pay for the actual value of the block instead of like having to predict correctly what the value would be. So honest builders cannot compete against this, and this is the centralizing problem. This is a problem. This is a problem that relay will always win. I think this is what Julian is pointing, unless I'm mistaken.
No, yeah, absolutely. Yeah.
So say the payments on the protocol, right? Then if you run the honest client software, like then some P2P bid will probably win because they have a higher value, and then you just choose a higher value, right?
No, but the point is that we don't want to have a system in which being off protocol has a clear advantage, because then every validator will be off protocol. We want to have a system in which being off protocol is fine. You could go off protocol if you want, but if you have a clear advantage of going off protocol, that's a system that breaks us.
that if you want to rely on altruism, don't make it expensive. Although it's not altruism, but yeah.
That's correct.
Okay, so just to walk through the logic, yeah, if they commit to, if it's a block auction and they're committing to a particular hash, then we force the sale at the time, and there's really nothing. I mean, you can get bids faster by using MEV Boost just because you have a point-to-point connection, but other than that, there's really nothing happening off chain.
Actually, you get bid faster by using the protocol instead of MEV Boost.
That gossip sub faster than
No, gossip is gonna lose anyway. Gossip doesn't exist.
So what do you
Forget
mean?
about gossip.
I just mean like getting the bids from the builders to the proposer.
Yeah, you get it directly. That's what the protocol hopes to get, that the builder connects directly to the proposer.
Oh, or is it okay? So builders will always like an HTTP endpoint, and the proposers would
Exactly, and then you don't, and the relay has an actual disadvantage. So even if you make a payment off protocol, you have a disadvantage.
So yeah, basically you set up your MEV boost to point at all the builders you like, and then you're farming that out. Okay, cool. And then so then you've got your bid. All right, and versus the slot auction, which enables this whole secondary market. And that's basically the crux. Yeah, I mean that seems reasonable to me.
We thought that the secondary market was cool because people at Rig wanted to have something like APS eventually. So if you have a system that eventually enables a secondary market, you can move this secondary market and shape it however you want, off protocol if you want. And then we keep the in protocol auction as it is with minor changes. But I think what this is showing is that that is trickier than what we thought. So what did Rig think about this, Julian? I assume that you showed them this?
Yeah, I showed them this. I think, so it's difficult for me, of course, to speak for them, but many of them thought it was a problem. I presented the arguments in favor and against those auctions, which is the Notion document. So I was part of a larger presentation. I think this was the main problem. Yeah. And so I think a secondary market is fine as long as you force the sale early via MEV burn as something that you would do in execution auctions. So if I could add to that, to me, it feels like two big considerations in blocker slot auctions are, so slot auctions, the thing I just presented, block auctions has the 3DA problem that POTUS pointed out, and also the missing or potentially builders not revealing their blocks if they later find out that it's unprofitable to publish them. And so I think these are, to me, it feels like this is the main trade-off.
What was the first disadvantage of the block auctions? 3DA, you said?
Yeah, it's
you can post a hash and the PTC would vote that the payload was available, and then you produce a payload that is invalid. So that payload is dropped by every node, but you can prove that you had that hash and that every node had that payload. So that data, it did exist.
Yeah.
You get this for free.
So is this a DA problem, a free DA problem?
Yeah.
Oh,
that's a DA problem that arises in block auctions
that
we do not know how to solve.
I see. Okay.
So I feel like the arguments in favor and against block and slot auctions are somewhat well known. So I'm just curious how we could move forward on that. Yeah, how to make a decision.
So I have an opinion on that matter. From the implementation side, these two things are very trivial. So we're still like far from having a DevNet, at least a few weeks. So my suggestion would be to stay as we are, which is on block auctions. We have a major change that we need to anyways rebase, which is this change by Lucas about the, I'm just gonna talk about this later, but it doesn't matter. Just to keep on block auctions, and whenever we make this decision, it's just a few lines of change. It's not a big change for us to move from block to slot auctions. At least this is not for Prism. So I think it's better just to continue on the implementation side while these discussions are carried async.
Okay, sounds good. I'm trying to find people who are interested in looking into how often blocks would be withheld in block auctions. That's probably like a research thing, and then I could update you async how that goes.
That's great. I'm still worried about this DA problem because I'm not sure how much of an issue it is. I can definitely see a market for a rollup that requires the validators to be live.
I mean, dumb, like, I don't know. This has probably been thought of before, but like, if presumably you can have an on-chain aggregate attestation by the entire PTC saying that the block was invalid, do you really need to include the block on the chain?
No, but the block is never included in the chain. So because this thing is invalid, you drop the thing. But the PTC, so in principle, you could make the PTC evaluate the block and check that it was invalid, but we don't want to have this because this puts a high requirement on the PTC. This puts execution on the PTC, which is the big win of ePBS, is that you delay the validation of the block. Now you're going to put the validation of the block in under 1 second, which is just tough.
I see.
So another one, which was, so there was something, so that comment. I don't know how to solve the free DA, but also it's not really clear how much of a big problem it is. Like when I mentioned this, Francesco seems skeptical that this is an actual attack. To me, it sounds like a really serious attack.
I guess it would depend on one of the things it would depend on is the relative price between like DA and execution. And like DA is pretty cheap. So like, having to outbid like valid execution and pay that could be, not that we necessarily want to rely on this, but it's just my thought is like, if DA remains cheap, you want to go outside of the 4844 mechanism and soon pure DAS, which with prices on one GUI, at least at this point, just to have some DA, I don't know.
Yeah, but the thing is, what is that you're pricing, right? So today DA is cheap, but that means that you can send a bunch of transactions with a couple of blobs cheap. But with this, you can send a full payload that's several megabytes. So you can send a full payload, and every single blob because the KCG commitments anyways are going to be there, and you get all of those for free. So you get several megabytes for free, or for whatever the bid was. So as long as those megabytes are cheaper than the MEV payment on a block, it's rational for you to post that way. If you only need it sporadically, right? You only need it for one slot.
Yeah. Is there ever like
the good thing about this is that if this becomes a serious attack, the network can react quickly, because it's someone, and we can even slash the builder anyway, but the network will react quickly, because you need to have a series of validators who will participate on this, and you can blacklist them immediately. So if you see a builder proposing invalid blocks, validators would immediately check it, and vanilla validators can blacklist immediately the builder. So a rollup doing this seems like unfeasible. But still, it's an attack that is out there.
Can be something in protocol here, potentially, where you see the PTC voting everything, and then the block is not included, so you can afterward penalize this situation.
Yeah, like could we decouple the like if you don't reveal, or like if you reveal your when you have a commitment on chain, you're like on the hook for that amount of money. Can we decouple the amount of money that you're on the hook for including a block from either having an invalid block or not revealing?
Yeah, so that was the proposal of Lee from Offchain Labs. Just penalize after the fact for the DA, for the maximum amount of DA at the gas price that you could get, which is something we can do, but it definitely complicates the protocol, because you need to go back and see what the builder was, and then you need to get you do have the builder's commitment, but also it becomes another attack, and you need to start like studying what are the for choice implications of this, because every time that a payload is reordered now, that builder would be penalized. So you need to prevent this. Now you're going to have to be enforcing a PTC commitment being on chain. So today the PTC vote is never enforced on chain. It's only put on chain to reward the validators that attest it. But under this penalization, you're going to have to keep the PTC vote on chain and make it a matter of consensus, more than just for choice. So I think it's like the complication of like penalizing for this is just too much, or at least it's a level up from what we have today. Anyways, I think it became clear that Julian made an exposition that there are these trade-offs. We seem to have like serious attacks. It seems to me that the slot auction attack that was presented today seems pretty bad, at least at the moment. I can't think of any way of solving this. Like shipping the whole thing so that people just anyways bypass it, and seems unreasonable.
But this requires like client changes, right? So you have to modify your client entire like consistent client code for this.
Not really, because you're gonna, so the client, the builder API is going to be completely covered by us. So keeping a map boost fork that uses the client is going to be a very minor change. I mean, a very minor fork. It's true that you're going to have a fork that that doesn't connect to anything and it just commits to yourself.
Right.
But map boost is going to be essentially supported, right?
Yeah.
Because we are going to be requesting bids from builders directly. So that's all that they need.
Right. You basically just commit to yourself, and then you basically don't check any bid value from everybody else. That's it.
Which is anyways, that thing is going to be a flag, right? So I'm sure Prism at least will include a flag that says build locally, meaning just commit to yourself. So the fork of Prism, I think, is going to be easy to make. Well, we do have, unless someone has more comments about this, we can move on the agenda. We had Mark wanted to discuss something, and Terrence wanted to discuss something. So we can go with Mark.
Sure. I mean, I can post a link. I can share my screen, although I have a lot of screens, so it might take a while. Maybe I'll try sharing. How do I do this in Zoom? No, maybe I'll post the link. I can't figure out how to do it. It might take too long. Okay, so this is just I posted in the chat. There's thank you. A link to like just a simple engine API method. It's basically the exact same specification as get payload bodies, except you return the whole payload. It's renamed as get payloads because you're not getting a body, you're getting the full payload. Maybe we could just make it a get payload bodies v4 and return the whole payload and say that's the thing. I mean, it doesn't really matter. That's just semantics, but this is all these. I just wanted to have something written that was like concrete, that was a proposal, so we can talk about it. Not that this is the end all form of the method, but the reason we have this is like the consensus node often doesn't want to store the beacon or the execution blocks because the execution layer will already do that, and then you're wasting disk space. So we created this payload bodies method so that because the consensus layer stores the headers, if you can just get the bodies, the transactions and stuff, combine those with the headers, you can get back your full block. And so you have that saving of space, but now we don't have headers. And so if you want to have the same saving of space where the consensus layer doesn't keep the full execution blocks around, you need some method to get those execution blocks from the EL. Right now, there's two reasons to do this compared to using something like ETH get block by hash. Number one, ETH get block by hash doesn't accept a range, and we're often getting range sinks. I mean, the main reason to do this is that you're getting range requests from other nodes in the network. And number two, if we use get block by hash, we would actually have to have RLP in the consensus layers to decode the transactions and get them in the form that we need. So yeah, it's just not designed for consumption by the consensus layer. But yeah, like basically, if we don't have this, our options are use ETH get by hash and put RLP in the consensus layer, or have the consensus layer store all the payloads and duplicate the space because the execution layer is already doing that.
Can I ask a very naive question?
Sure.
I don't understand why we even need to. So I honestly don't know how the EL syncs. So why do we need this range request?
I believed it was for CL syncing, actually, not EL.
But that's my point. So for CL syncing, you kind of need it now because you need a block. And you need, I guess, the block hash. But for CL syncing, all you need is the blinded envelope. And because the blinded envelope has the right hash, and you don't need to validate the payload for CL syncing.
How do you get a payload for CL syncing?
But that's the thing. So if the EL is syncing, the EL knows that if the hash is valid or not, because the EL is syncing independently on their own. So it's my lack of knowledge as to how they are syncing. But my understanding is that if they can sync independently the blocks, and I told them, sync to this hash, this is my finalized hash.
Yeah, I mean, right, so I'm looking at the P2P interface. So first of all, there's a couple things being said at once here, which is number one, are you saying that the CL doesn't need the payloads when syncing?
So the CL, our syncing spec says that we need to submit the payload to the engine to validate, and we need to wait for a request from the engine. So therefore, we do need the payload. But my naive question is, why do we need the payload?
Okay.
If the EL can sync on their own, and we have the hash, and we tell them, I've synced up to this point, and this is the hash, is it valid or not? And the EL tells me, yes, it's valid for this height.
So
Why can I not take it?
You still need to process the payload though. You still need to process the payload, right?
The CL does not need to process anything. The CL needs to process the payload envelope, and we have
Yes.
the blinded envelope is everything that the
Oh
CL needs to
yeah,
process.
you're right. That's right. That's right.
The only thing from the payload today that we need to process is withdrawals
right.
that is outside of the domain of the payload in ePBS and even in Electra.
So you're asking basically like why during syncing do we need to keep sending new payload, new payload, new payload, new payload to the EL when it can
Correct.
based on the hash and just sync? I think the answer is we actually don't, and there is a minimum amount of validations that we need to do, and those can be found in, like, if we don't send new payload, there are still a minimum amount of validation.
Yeah, you're talking about the block hash, but even
Yeah,
that,
the version
I
hashes,
don't.
the block hashes, and like, I don't know if there's
Even that, we don't need to do anymore because we don't even care what the content of the block is.
okay.
That's
I mean, the reason though that we have to do the block hash has to do with a specific kind of attack. Like, I know that at least for withdrawals, I can describe this attack. So if you can force the
yeah, but because withdrawals is part of the block hash, but
yeah.
starting with Electra, well, I don't know about Electra actually because I think they probably still use it for RRP, but definitely on ePBS, if we move to SSL, we don't care about what the content of the payload is. We don't need anything from the payload, nothing. We don't care if the hash is even wrong.
We do in terms of like the execution payload saying, or the execution engine saying that the block is invalid, that it can no longer be the head. I mean, we can.
Yeah,
but
that's why we only need the actual hash to send it to the EL, and the EL would reply, yes, I have this block, is valid, or the EL replies, no, I have this block and it's invalid, and that's it.
okay. I mean, so let me try to explain this attack if I can remember from memory. So I think the idea is that you force, if there's a mechanism of forcing the EL and the CL into or like the EL into the CL into optimistic sync. If you can do that, and you have this situation where the CL is not sending every payload to the EL, then what you can do is release two blocks which are different and where the validations between the two don't match up. So like it's wrong on one side, but that side doesn't validate it, and it's wrong in another way on the other side, and that side doesn't validate it, basically. So for example, with the withdrawals, like on the, I think, let's say on the CL is what validates that the withdrawals are correct. And so you release a CL block with correct withdrawals, but with the wrong block hash. And then on the EL side, you release like this crazy withdrawal which isn't correct, and then you calculate the block hash correctly, and that's the block hash you put in the CL side, if that makes sense. So you basically have two blocks, but they have the same hash, and on the CL it's incorrect hash, but the CL has the correct withdrawals, and on the EL you have an incorrect withdrawal, but the EL doesn't verify the withdrawals, and then you have the correct hash.
Wait,
So you have two
but the
blocks on
EL
it.
does, but the EL does verify. So when you send, so
The EL can't
when
verify
we
the
send the
withdrawal.
payload for validation now, when we send the payload for validation now, we need to send all the requests. So this includes withdrawals.
Yeah, but the EL doesn't verify the withdrawals because it can't.
No,
It
but
just-
the EL
it-
verifies that those withdrawals are the requests that they are fulfilling in that block.
The EL can only get the withdrawals from the CL, like from
Yes.
the payload on the CL.
And that's fine. We can still send them without having the payload. We only need the withdrawals. So that's my point, that to the EL, we can send a blinded envelope. And the EL can verify that the requests that I'm sending match up.
So I think, yeah,
Well,
maybe
actually, it doesn't matter. The EL only consumes the request from the envelope. Yeah, actually, I don't know. Let's think about this.
I mean, did what I said make sense though? Like where you kind of have two blocks, but they're the same.
It does, but this is a problem that we have today because the withdrawals are within, and it's part of the block hash. I think it disappears once we just have this SSZ object, and the withdrawals are outside of the payload.
Yeah, I mean, it's a good question. I'm not sure I am fully across why. Like all I know is that this verify and notify new payload function in the spec, which almost no one talked about this function, but it has a number of validations in it. And these are the minimum amount of validations that you must do if you do not send every payload to the EL.
Yeah. So it's just the block hash validation. I understand. And Prism might be probably the only client that doesn't do it.
No, you're not.
But
It's only Nimbus and Lighthouse that don't send everything to like you don't have to do these validations if you send everything a new payload.
Yeah, I understand. We never wanted to implement this RRP thing so that we don't need to check the block hash.
Yeah,
we probably should.
If you do, and that's fine. If you send every new payload request to the EL, and that's what Prism does, then this is fine. And everyone except for Lighthouse and Nimbus send every new payload request. And so Lighthouse and Nimbus are the ones that have to do these extra validations. But these attacks are somewhat complex, and I don't understand them enough to say that it's fine, you know, to not send new payloads. But what you are proposing, right, is to not send new payloads and just have the EL sync on its own.
Yeah, so I'm proposing that optimistic sync needs to change. But okay, so to be practical in this meeting, I think what you're proposing for the engine API is perfect because it's the minimum change so that we keep the things the same way that we are now.
Yeah.
But and yes, we should probably move along with that. But at the same time, I'm gonna start a call with Misha and try to see if we can just get rid. If after accepting SSZ on the EL, we can get rid of these things.
Yeah.
You still need a new engine API call even for that, right? Because you need to pass in the payload hash to this EL, and then the EL will return valid. But then in this case, it's just a payload hash.
But we have the hash from the bids. Like that is something we already have, and
so you can just use that basically. Yeah.
All right. So does anyone have a comment about this engine API method? If people have seen it, I mean, anyone disagrees with implementing it this way? Because we haven't made any changes on the engine API. This would be the first new method added to the engine API. Ethan also suggested the same thing. All right, so that seems reasonable. Terence wanted to discuss moving process withdrawals to the execution phase.
Yeah, I guess just briefly, right? Because I feel this is something that people has brought up every 2 weeks. Basically, people ask that why can't we not do withdraw on the execution phase? What does the withdraw currently has to be the consensus phase? It's because the withdrawal is originated from the beacon state and then it's redeemed on the execution phase. But we also could move withdraw to the execution phase if we want. But then, I mean, I think currently it just feels safer, more nature to do it on the consensus phase and then just block on the execution if there's an empty block, basically. But we could also look into moving to execution phase. So I'm not sure what's the best step forward.
To me, it doesn't feel safer, I guess. I mean, I could be convinced it's safe. It's just that I have to sit there and think about it. Whereas it's like it seems immediately obvious to do it on the side of, because like, you know, like the way that it was framed in the spec is the state transition has been split into 2 phases. And so like, let's just do it on the phase that is processing the execution payload side. And you know, it kind of already to some extent needs to be done there. I mean, not if we do caching, but you already are checking that the withdrawals root matches, which is the same exact check as what used to be in process withdrawals. So it like, yeah, in a sense, to me, it feels actually like it's more similar to what we have pre-EPBS because.
Oh, no, wait. So it is, sure, in the happy case, it is exactly what we would have pre-EPBS. The problem here is that withdrawals affect the safety of the beacon chain and they affect the economics of the execution layer. So if you get a wrong withdrawals on the execution layer, you can get paid. But if you get wrong withdrawals on the beacon chain, you can get out, like say, slashed money. And there is an actual change. What is the difference of executing it? And I'm not against moving it to the execution side, but there's an honest difference, which is the following. Let's suppose that I today withdraw with the current specification. I send a withdrawal and this block lands and I withdraw. So my withdrawal is going to be deducted right now on the beacon chain. And now let's suppose that the next 1,000 blocks are missed. Not missed, but empty. There's no payload. There's a liveness problem on the chain. Now my validator is leaking, but it cannot be leaked because I just already withdrew. So the 16 withdrawals that were included in this block were already withdrawn on the beacon chain, and they need to be fulfilled on the execution layer. If we go with the design where we only process on the execution layer, then my validator would be leaking for 100 blocks. And what I would withdraw would be different, would be a different value. So the effective balance might have changed, and so it has an effective balance change. So these 2 withdrawals are effectively different, and we need to verify that they are safe.
I guess I just don't follow because, like, you send a withdrawal.
Yeah.
Okay, so does this have to do with the ordering of process withdrawal requests versus process withdrawals? Is that what this comes down to?
No, forget about the withdrawal request.
Okay, but I thought you said you send a withdrawal.
I send a withdrawal. Like I withdraw my validator. I exit my validator.
Oh, okay. So like you exit
whatever form of withdrawal.
Okay.
Even if it's a partial withdrawal, it's fine. Suppose that my validator was to be partially withdrawn now in this block.
Yes.
Currently, I would partially withdraw like 0.1 ETH. And that's it. That needs to be fulfilled in the next payload.
Yeah.
But if we go with the payload one and there's 1,000 blocks, I can actually leak during those 1,000 blocks. And then when the next payload comes in, I don't withdraw anything. See, so this validator in one scheme.
This implies the existence of a queue, sort of?
No, there's no queue. No, there's nothing. The beacon chain continues advancing. If there's 1,000 blocks where beacon blocks are coming,
but
yes, and the payload is not, I might even be slashed during those 1,000 blocks. So this validator that could have been exited or withdrawn or whatever in this block on one scheme will not be exited or whatever or withdrawn, and might even be slashed in the other scheme. So these are different outcomes from the beacon chain perspective. And we need a 4-choice analysis of these outcomes. So
Okay.
I'm not comfortable changing this without getting that analysis. The current design is such that on the beacon chain is exactly as we have now. And
Doesn't
on the EL side is different.
Turn like process withdrawals effectively doesn't run if there's no payload the last time.
Yeah, but the first one does. So it only affects one block, that I agree. It only affects the last block before the liveness problem. So there's 16 withdrawals that will be different.
Okay. I guess, yeah, I'll have to think, but my thought is that this whole thing just shifted one block and that I don't see how the attack is different, but I'll have to think about it more.
Well, because the withdrawals are something that is determined by the beacon state at the point where you process them.
Yes.
So if we're not freezing and the beacon state keeps advancing without payloads, then the withdrawals might be different after 1,000 blocks that are missing.
Oh, I thought the withdrawals would freeze effectively because process withdrawal doesn't run. I thought in
No,
both
but
frozen.
But withdrawals don't. The thing is that the beacon state is different. So you're not processing a partial withdrawal of a validator that got slashed, for example. Process withdrawal is not doing anything, but the beacon state is changing. Therefore, the withdrawals that you expect when you call process withdrawal now or 1,000 blocks from now they're gonna be different.
Okay, and you said it was 16, so like basically if you're the guy who's getting a withdrawal in 2 blocks and then this thing happens, you're out of luck and you're in the same position, is what you're saying?
Yeah. So yeah, that's correct. So the only thing that changes is for the guy that will be withdrawn now, and then suddenly it's not.
And that I
don't think it's. I agree that I don't think it's a dangerous thing, but we don't have that danger analysis.
I mean, yeah, we could think about it, but that seems like so. I don't see how if one is preferable to another. I don't know.
Well, the
I would be surprised
current, the
if that
current one
matters,
has
but-
exactly the same behavior as it is today on the beacon chain. The other one would be a change in the beacon chain.
I see. Okay. I think I see what you're saying now. In the sense that like I see because currently the beacon chain cannot progress without the execution chain progressing at the same time. And you're just saying that like if we know that, okay. Yeah, I would be really.
I definitely prefer to move it to the execution.
Extremely surprised if it mattered, but
we are on the same page, and I also
Yeah.
prefer moving into to the execution. But I would want someone to actually think about this problem before we decide this. I want someone to assert, yes, this is safe. I thought about this. The changes are safe. They seem safe to me, and it also seems like an easy change on the spec. So that's why I'm not that worried of doing it earlier or later.
yeah.
So I'm not sure about what the status of implementation is. For us, it would be easy to change it now. We already implemented this, but it would be easy to change it now. So if people haven't even started doing this, we can change it. And it might be simpler for everyone.
Yeah, I haven't implemented process withdrawals yet because I got stuck on it when I didn't see that one line, but it would definitely be simpler for me to implement just because it requires no changes to the process withdrawals function. So I mean, that's just easier, and there's like no changes to the function, but
Yeah, it also has an advantage that you don't need to have this extra field in the state.
yeah,
And a cache is always ugly. So I do agree that it seems better. Why don't we run a poll in Discord? Because we're already over time. Why don't we run a poll on Discord and then decide what to do?
sure.
All right, people. We are already over time. I don't know if people have more comments.
Thank you.
All right. Thank you, guys. I'll see you in a bit.
Thank you, guys.
Yes.
Bye.